Good day, everyone. I am Mrs. Mountain, but you can just call me ma'am if you may. Today, I am going to be your teacher. I am your educator for today. I am going to be doing geography with you guys. I am going to be touching on grade 10 geography, grade 8 to 10 geography. We're going to be touching on geography specifically. We're going to be learning about contour models and landforms. Now, we obviously do know contour lines, contour intervals, and landforms. We've obviously done them from our previous grades. But today I will be explaining them thoroughly, and I will be giving you a brief explanation on what those are. I have a model designed for you for reference, which is this model in front of you. I hope it's clear and I hope you can all see it. It is a 3D model and it looks somewhat real. I hope everyone can see the model. Without rambling too much, let me just get into the lesson of the day. I hope everyone is ready. I hope everyone has their pens, their pencils, everything that they need to write down notes. You may write down your questions. I'm going to be taking in questions at the end of the lesson, and I'm going to be giving you a homework, and I am going to be answering questions. I'm not the one who's going to be answering questions only. Everyone is going to participate, and I hope you're going to have a great day. So without talking too much, let's get into the lesson of the day. Some of these features you would have done them already in your previous grades in terms of mesas, buttes, saddles, and etc. Let's start by looking at the landform known as a mesa. We know, first of all, that a mesa is associated with horizontal landscape. When looking at this landform known as the mesa, we notice that the width is greater than the height. In essence of the width being greater than the height of a mesa, this tells us that it has a large flat top. As we can see down here on the model, there is a large flat top. And also, when we look at the contour map, we can see towards the center that there is relatively large area with no contour lines. Looking at the diagram below, we can see that there is a large flat top and there is no contour lines. There is only contour lines around the mesa. This tells us that there is a large flat top. Contour lines are generally closer around the flat top, indicating great steep gradient. As we can see on the diagram below, on the landform mesa, there is a steep rock, or what we call a hard rock, a steep crack, or what we call a hard rock. This is in result to the generally close or closer contour lines around the flat top. There are no contour lines on the flat top. There are contour lines around the flat top, as we can see and as we can read on the chart. Let's go ahead and look at the saddle next. Alright, I'm sure we can all see the saddle down there. It is in the color purple next to the spurs right below the butte. I know when you think of a saddle, your minds are thinking of the horse saddles. If you look at the shape very clearly, if you take time to look at the shape, they do look alike, or they do look the same. But that's not the point. We are here to read geography, not horses. Looking at the saddle, it is the lowest point along the ridge between two mountain tops. It is the lowest point. I'm really sorry for the disturbance. My camera cut, my battery died. But without rambling too much, let me just pick up where I left off. I will repeat what I said. Looking at the saddle, it is the lowest point along a ridge between two mountain tops. I am certain you are able to identify the mountain tops surrounding the saddle down below. On the diagram, the purple mountains, and in between there is a saddle. Looking at the diagram, I have identified or labeled the saddle to be in between two mountains. The mountains are high top and the saddle is low. It's a low point. It is an area between two high points, as I've said before. It is also important to visualize it for easier understanding. Just visualize what I'm telling you right now. Visualize the two high points and a low point, and you will just get the easier picture of what a saddle is. Let us take a look at the butte. You would have done this in theory already, and let's identify the butte in the green next to the value right there on the diagram. We can see, or we can identify that the butte has a very small flat top compared to the mesa. The height of the butte is greater than the width, just like the mesa, but the flat top is smaller compared to the mesa, where the flat top was a bit larger or a bit bigger. A butte is a tall, flat-topped hill, steep-sided tower of rock found in landscape with horizontal strata. The contour lines are generally close around the flat top, indicating steep gradient of the steep cap or hard rock. It is much similar to the mesa as we've spoken about it earlier, but the difference is it has a smaller flat top. On to the next landform on the contour model. Now you would notice that the conical hill is much smaller than any other landforms on the contour model. That is because there was no space, unfortunately, and I have labeled it with a marker on the contour model. That is because the label was going to be too big. It is in the color red next to the spur and just underneath the mesa. So without further ado, let's get into what a conical hill is. When looking at this hill, we do not have steep and just then sudden, all of a sudden, gentle slope. It is evenly distributed, or we can just say it has quite a uniform and evenly spaced out. That is how we differentiate between a mesa, a butte, and a conical hill. Those are the three hills: a mesa, a butte, and a conical hill. A conical hill is a result from the action of an entrenched river that has deeply cut into a plateau. There are no horizontal cap rock and has much gentle gradient. As you can see on the contour model, there is a gentle gradient compared. There is no steep gradient. It is much gentle. It is more on flat, if you can say. There is no horizontal cap rock and has a much gentle gradient compared to a butte and a mesa. There is really not much to say about a conical hill. We can just see that on the diagram, and you can just visualize it, or you can just imagine what a conical hill is or what it looks like. So far I have covered all 5 landforms, as you can see there on the contour model, on the contour model and on the chart. Now I'm just gonna have a quick recap in conclusion. We have there the mesa on the chart. As we can see, the mesa is associated with horizontal landscape. As I have explained, the width is greater than the height. It is relatively large area at the center with no contour lines, as we can see also on the contour model. It has close contour lines at the top, at the flat top. Now we're gonna go and recap also at the saddle. It is the lowest point along a ridge between 2 mountains. There is nothing much we can say about the saddle, but also we have the butte, and the height is greater than the width. Similarly to the mesa, it is a tall, flat-topped hill, steep-sided towers of rock, and close contour lines around the flat top, similarly to the mesa. we go ahead and look at the conical hill. We have it is a result from the actions of an entrenched river. There are no horizontal cap rock. This is similar to the Mesa Butte and the conical hill. They are all three hills. The valley and spurs is the low point area between mountains. The spur is a hill or a mountain projecting in lateral direction. Now, for your homework, I am going to need everyone to write down these, but also you need to write down all, or at least 20, 15 of landforms, including these ones. These ones are 5. You can add more. You are going to explain them and you are going to do your own contour models. It can be as large as this chart over here. You are going to be creative, use all your colors, use your brains, be creative and think out of the box. You can use different materials when coming to the contour models. You can draw the river, or you can make a river as or from paper mache. You can also do different contour or landforms than mine. You can also label it differently, but it needs to be, or it can be, as large as this chart over here. It cannot be small because not everything's gonna fit. So without rambling too much, I hope everybody understands, and I hope you get what I was teaching you about for today's lesson on contour model and landforms. Thank you.